Hey everyone, for those who have arrived, thank you very much for doing so. We're going to start in less than 1 minute. Give people a little bit of time to get into the room, and then we'll kick it off. Hi everyone, and thank you for joining us today. My name is Al Sargent, and I lead product marketing here at ZEDEDA. I'm really excited for today's webinar, which covers one of the most challenging issues today in edge computing, which is how to get your edge AI projects unstuck out of the pilot phase and into production. But before we dive in, let's do a little bit of housekeeping. We're recording today's webinar, and we will make the replay available to all of you so that all of you can share with your colleagues who were not able to join us today. Second point I want to make is that to submit questions, please use the Q&A feature at the bottom of your screen. So with that, let me go ahead and introduce our speakers. We have Sachin Vasudeva, who is our VP of Products, and Rob Bush, who is our Senior Training Manager. And today, Sachin is going to cover the Edge AI landscape, where it's been, and where it's headed. Let's go to the next slide. And then he'll talk about how you can navigate your Edge AI journey and how to get your projects unstuck and into production. And then after that, Rob will demo our Edge Intelligence Platform, which helps you accelerate your deployment of Edge AI. And then finally, we'll wrap with Q&A to answer your questions. So with that, let me hand it over to Sachin.
Great. Thank you, Al. Appreciate it. Hi, everyone. Happy to be here. Let's jump into the landscape for Edge AI. So, you know, just a quick context. The application space is really one of the biggest drivers for gets deployed at the edge and how it gets deployed at the edge. And when we look back in the last several years and decade even, we see this applications such as a Windows application or even older traditional apps where the data, the business logic, the user interface, the actual databases, sometimes they all get combined into one single application and they get deployed. Over the years, the natural evolution that occurred was in the IT side, applications started to separate out. This notion of microservices appeared. And what happened was it also increased the overhead in terms of how applications managed a set of different functions within these microservices. And it also decoupled the notion of where the databases were sitting, as well as the user interface were also decoupled. So front end, back end became more sort of separated, and APIs were the means for communicating back and forth. However, now with Edge AI and the agentic landscape, there's another evolution happening, and that is really continuing to base the fundamentals on this microservices architecture, where you see a vision application, and the vision application relies on the model data that's coming in. The vision application relies on a model itself. So the model is used for inferencing. The model's capabilities are set up in some model context, model file, and and then apart from that, there's a set of additional capabilities that are encapsulated in another set of microservices. So the pre-processing logic, the post-processing logic. So let's take an example for vision. When you attach an IP camera to an edge node, you are in your pre-processing logic, you have to set up the frames per second because your model may have a certain expectation in terms of how it's processing and inferencing. Once that pre-processing logic is set up, then the data sort of flows into this model inference file, and then the inferencing is sort of starting to happen. When that happens, the output of that inference could be pushed into the business logic side. The business logic then starts to act on the data. Apart from this, the model data gets encapsulated sometimes because you want to understand the performance or the accuracy of the model itself. So whether there's a drift happening, whether you need to retrain the model at the edge. And then finally, with Gen AI and large language models, it's even sort of more evolved. So you'll see this notion of a vision language model, VLMs or LLMs, and they are now sort of themselves acting as agents. They can, sort of work with an agent called, let's say, NemoClaw or OpenClaw, if you guys are familiar with that, where it's acting as a gateway application, and in the backend, it's also referencing these LLMs. So the evolution is happening very quickly, and we are, sort of understanding this evolution. The other piece to note is um, the dependency. So the hardware itself. The edge gateway now includes CPUs, but not only that, there's GPUs. There's integrated GPUs, so SoC-based systems such as NVIDIA's Jetson family, as well as NPUs. And then, in the market, if you've seen LPUs, which are LLM processing units that now NVIDIA has acquired. So a lot of different variety of hardware, diversity of hardware, chipsets. Sometimes they are PCI accelerators, sometimes they're just SoC-based GPUs. So we have to be also aware of those as well. So the application dependencies on the southbound side have grown, and how the application performance happens there determines how the application architecture northbound gets set up. So all of this becomes a super interesting driver at the edge for how we want to continue managing edge applications, edge agents, as well as these older legacy applications. So now another part of this challenge and the landscape is really the notion of adoption itself. So we've seen from past couple of reports, first and foremost, the maturity of the organizations have an important role to play here. One, either, even if it's a highly mature organization with a lot of process, it takes a long time to adopt some of these new techniques into the organization. Or even if the maturity of the organization is not as high, however, the idea of then iterating fast and failing fast could still result in no results. So the outcomes could still be, questionable because you're going so fast, you're going and setting unreasonable objectives. And what happens is that they don't result in the right outcomes from an executive sponsorship point of view. So overall, we are seeing some data points where either pilots are failing because there's no measurement on the impact itself, or it's about the fact that the majority of the organization and they are struggling to figure out how they scale, how they adopt, how they even get started. So the AI initiatives, however, are what we believe are going to continue to happen, and companies will continue to provide a lot of support and energy behind it to their employees, to also third-party systems as they try to unlock the value of AI. We'll also talk about some of the use cases that we are seeing across the board with some of our customers when it comes to Edge AI. So that will hopefully help understand the language as well as the landscape that's already either adopted or is in the process of adoption. So first and foremost, with SLB, where thousands of edge gateways are deployed, and whether they're next to an oil rig or next to a well site for drilling operations and understanding how that's happening, or from understanding the quality of the drilling operation itself. In all these scenarios, different variety of edge AI use cases are being deployed. So there's a vision application being deployed on the oil rig. It's likely for worker safety. So it's a red zone detection. It's a worker safety PPE detection, whether somebody's wearing a hard hat, they're wearing protective goggles. So and maybe sometimes you don't need to be in a certain area which is cordoned off. And so the timeliness of these alerts making their way back into an administrator or someone who has the authority to then help remediate the situation is important. Number two, you have to also make sure that the application continues to perform and operate over a long period of time. So if there's drift, if there's any changes in the data itself, we have to ensure that there's a fast iteration, a fast update. You can easily remediate the drift in the application vision detection algorithms to say, yeah, here's an updated version, and that will help sort of offset any time downtime. So the other interesting piece here is that there's also a notion of an expert or a subject matter expert that now comes into play. What SLB calls a drill master. A drill master has 30, 35, 40 years of experience where they have spent a lot of time and energy understanding the efficiency, the operational capabilities, the outcomes, and all of that knowledge is buried into these masters, drill master, skill sets. And the idea is to transfer these skill sets into AI. And so that's again one more use case where you'll see a subject matter expert and the training being applied to bring an AI system to maybe some degree of that. Maybe it's, getting to 40% or maybe, 70% of the capabilities of a drill master. So again, and then once that happens, that gets deployed at the edge, and then it has to do, perform certain functions. Another set of interesting use cases, let's take automotive. So if you have tens of thousands of dealerships worldwide and you have vehicles rolling in, day out, with either, data on them in terms of what sort of, service information they already store on themselves in the car itself, and then what sort of vehicle maintenance is needed based on the car, the model, whether it's an EV versus non, and so all that data model, the entire set, all has to be stored locally. It cannot be stored in some centralized cloud where it's fetched in real time as cars are rolling in. So you need to be able to have a certain latency. You have to be able to perform certain vehicle maintenance updates as needed, and you have to be able to predict. Uh, in some cases, some vehicles may need further maintenance as soon as they roll in. So all of these data points, all of these insights have to pop up on the terminals, which are being hosted all locally inside these dealerships. And so again, the use cases become super obvious. How do you ensure, number one, these apps are up to date based on how they're predicting the necessary needs as well as the performance of all these vehicles rolling in. Second, it's the data models themselves. How much caching, how much updates of those data models, they all sit as part of an application itself and large databases. So all of them have to be updated on a frequent basis and in a way that the dealership cannot lose data when vehicles are being updated with their maintenance information. So a lot of sort of handholding, orchestration at the same time, data plus application logic all working cohesively to perform these functions. Next use case that's interesting is on the mobility side. So let's take an example from Maersk. Maersk, what they're doing is they're carrying all these large containers, and there's roughly, hundreds of these ships all going from point A to point B. They have certain challenges. Number one, their connectivity is a challenge. So they may have some dark zones. They may have some reduction in bandwidth, latency, and jitter might be experienced when that happens. Besides that connectivity angle, on board within the ship itself, there's thousands and hundreds of thousands of these containers that are maintaining this environments within themselves. So some of these have sensitive temperature monitors and sensors, in which case they have to maintain at a certain level. And all of that has to be monitored on a timely basis. And as soon as an issue occurs with one of the sensors, it's got to be somebody has to be alerted. Someone has to go check it out. and there has to be an auto remediation in place where you can have a backup if needed. So all of these again get embedded into the software logic. They get embedded into where these applications could be running, and they have to be always on. If a node failure occurs, it has to be failed over to another node. So you now need redundancies, high availability, as well as connectivity, right? So either it's a Starlink access, or it's a 5G or a 4G combination, depending on maybe it's all of the above. So imagine then the infrastructure needed here, where the chattiness, in terms of the liveliness detection, in terms of the keep alive, in terms of the state being monitored, all of that has to be coordinated. And then when the actual prediction logic occurs in terms of, well, some of these containers may run into issues based on the data sets, then what do you do? So all of that has to be then again coordinated in a way that that helps the people on board manage it super effectively. There'll always be a little bit of downtime here and there, but most of the time, the idea is to ensure that you can update the application in as real time as possible. You can update the data sets as much as possible. You can update the actual infrastructure, where it's Kubernetes, for example, also as much as possible, and in offline mode if needed as well. Next use case is, well, we'll sort of then move into what we call the journey itself. So hopefully this gives you an idea of all the landscape and the type of applications out there that are being deployed or planned to be deployed. Now, when it comes to the journey at the edge for AI, we've broken this into four phases. The earliest stage is where the largest friction is, where pilots are happening in parallel. There's a lot of motion. And as we discussed, the maturity of the organization really drives how quickly or how slow you need to move. But the outcomes is what moves it to the next phase, which is you're off from the pilot point of view and into a operational deployment angle. Now, when you move to operational deployments, the idea is when you move it out of the lab, does it actually work in the field? A lot of times a model gets trained in the centralized cloud. But when it's actually getting deployed on a Jetson hardware with an NVIDIA GPU, you're not really sure whether your model is going to perform in the same way, because you have to retest probably the latency performance. Similarly, the idea here is when you are actually even validating that hardware model and the hardware diversity behind it, and you're making these hardware choices, now you may have to remake that hardware choice because maybe you hadn't thought of the fact that your model needs certain tops throughput or performance in order to do a better job of the same consistent latency that you observed in your lab. Once you go past that, it's about scale. How can you sort of run this across the fleet? How does this happen in a single click format? How do you automate that? This is a day two operation, and it's clear that a lot of enterprises struggle moving from day zero, day one to day two because you have not set up the right automation. You need to rely heavily on APIs, on ensuring that every task is reachable through either a direct API access or now through some of the means that is easy to integrate with other workflows. And lastly, when you've sort of achieved all that, you want to really think about, well, how do you then, once you're running this inference at the edge, how do you then start acting on that? So again, closing the loop, what does that action look like? Is it remediation? Is it improving certain performance? Is it, maybe, an emergency action that needs to follow up through another workflow? So all of that has to be considered into what other ecosystem you have to plug this into to make it, super viable and continue sort of uh, yielding the value of AI at the edge. So let's talk about a few things. So first and foremost, unclear ROI. So if you're in this early stage, ROI becomes the number one conversation. So, we've got data points when we ran our survey. where we see certain difficulties. We talked a little bit about it, right? So barrier to adoption is the idea of demonstrating the value, whether you've got investments that you can understand the cost, and sometimes it's even hard to understand the cost because your LLM costs are token based. So how do you map that to a predictable cost and then map that into the actual ROI itself? How would you then say the outcome will be, yielding results where the results are satisfactory? So all of that planning and exercise has to be done up front. It is a hard thing to do. However, the surveys are yielding the fact that when you start on this journey, there's some leap of faith, but if you can get data, for example, if you can get real benchmarking for the hardware at the edge, if you can get validation of these models upfront, right? So, for example, out there, Hugging Face provides certain benchmark capabilities. That's why they sort of show these leaderboards where you can see which model performs better, but they focus on the accuracy part of the model. And but if you had the latency performance of these models, you would actually be able to see and map that back into an ROI as well. Next is this notion of a hardware itself. So when you do have to decide upfront and you're thinking about the ROI, the cost of hardware plays a major role. But besides the cost, there's also the type of hardware. Today we have a lot more choices, and the choices are growing. So how do you make sure that number one, you have future proofing? So future proofing is an important point because you might start with a costly hardware, prove out the value or prove it in the lab, and then you move and shift to a smaller, cheaper hardware. Or maybe you do a combination. Maybe you do a hierarchical model. Maybe, at the edge, you have the cheaper model, and then there's a gateway above it, which is doing, a more heavy lifting and centralized processing at the edge. So again, this evolution, keeping this in mind, will help if, again, you have the ability to model some of this based on actual target hardware, based on actual models, based on actual performance of these models, and bringing all together as a set of data that you can then use to make a decision to say, we'll start with X and we'll move to Y over a period of, 6 months. So this actually starts to become real then as a plan for you to start moving forward. Another idea of mismatching hardware is around models itself. So some models, for example, Quen, 27B, Quen 3, these are great models, really good performance, but they require a minimum hardware and minimum memory footprint. So, but if you move to like Gemma 3B, you could really sort of bring down the cost. However, you lose certain speed, certain performance, and that impacts your latency. So again, back to the use case. If you prove out Gemma 3B and it works, that's great. In some cases, there are companies like Liquid AI that are bringing models that are purpose-built for the edge. And with different architectures, they have proven that they can bring vision language faster with even much smaller footprints by optimizing on how they consume certain, resources on the GPU itself. So again, the ability to understand all these different model options, mapping them back to the hardware becomes super interesting as a challenge. And all of that has to be done up front in order for you to justify moving ahead. Thirdly, once you move ahead into the next phases, you're now moving into an operational environment where you've got integration challenges. One, you've got existing deployments. So a lot of brownfield with SCADA systems today are running Windows applications. Even if these Windows applications have been running on these Windows, machines and these laptops or these, towers and desktops, there's a transition happening where you're trying to move this out to an industrial PC, especially in a manufacturing plant. Now, take that forward and now try running an AI application right next to the SCADA systems application, side by side on the same system. That's only going to happen when you're transitioning this application off from the Windows desktop over to a Linux system and then managing the system in a way that you can then deploy containerized applications while you have a hybrid virtual machine that's hosting the Windows app. Easier said than done. So again, challenge, how do you bring best of both breeds, where you need to bring a hybrid, containerized, virtualized, workload at the same time. On top of that, now you've got to again run these models. So the models need some extra resources. You need to now carve out more resources. So you need to look at the extensibility of the hardware, as well as you need to see which models actually will fit back into the same hardware. So again, existing becomes an interesting challenge. And sometimes you have to decide, maybe it's a separate hardware, it's not the same hardware. Maybe it's not worth consolidating all of these workloads all on the same single system, because then you also have to bring a notion of high availability, clustering, and all these other capabilities in order to bring consolidation. So again, choices to be made. And another interesting data point is progression. So you can start with a single node that you're deploying at the edge and move to a multi-node architecture where you're now consolidating all the applications, but also then having an elastic edge compute infrastructure that grows. And that multi-node grows from 3 nodes to 10 nodes to 20 nodes. But you have to remember that we're talking about the edge. So it's easier to create many single node form factors over a large cluster than create multi-node over a single cluster and manage it. Because again, workload consolidation versus application management over single clusters. So we've got to sort of weigh in the odds at the edge. Thirdly, it's about lifecycle itself. So, at the edge, starting with the operating system, managing the nodes lifecycle, that itself, is a task. And now adding infrastructure such as Kubernetes on top, and then finally the models themselves. So when we discussed some of the use cases, we saw that if your well site needs to be updated and some data point has changed, you need to push a new well site model that will decide certain features or certain aspects based on the yield. You have to be able to version it quickly. You have to deploy it. You have to test it at the deployment site, get the new data, and make sure it works, and then move it to production. So that's a life cycle from staging to testing to developing to finally production level model producing insights, based on data coming in from sensors. All of that requires a bit more handholding. So it also requires tools that are already in place today. So you have to have GitOps in place. You have to have some level of governance to be enabling someone to approve these deployments. And finally, some additional capabilities such as observability, whether you need to roll back if something bad happens. All of that is the lifecycle capability that needs to be available to you. Next is as you move forward, is the infrastructure complexity. So it it goes without saying that as you move from one site to the next site, or even if you move from a set of nodes deployed in one site to another set of nodes in the same site, the level of complexity increases. This is because number one, your each site or within each site, the reachability may be different. You'll have different network conditions. You'll have different constraints. So now marry that into as a overall fleet management that occurs across these sites and have the ability to track resource capabilities, network capabilities, storage capabilities. On top of that, model requirements. So model and applications need certain resources. And then overall, bring that forward, that becomes a lot of tracking. So the system of record where you need to put all this down, where you need to manage tens of thousands of nodes, where you need to manage all of this through a single control plane, a single pane of glass. And when you start bringing inferencing, it becomes sort of another sort of overlay on top. So that challenge is real, and the scale challenge will continue to be the case for majority of customers, even though they've done a good job on the in the lab. Lastly, the final thing is the action itself. So once you've gone past the hurdle of deploying these applications and these models, and they're producing, they're inferencing, you're seeing these results coming in. Now you've got to really act on them. So this is where the evolution of the agent starts to show and play a role. Are you able to quickly and rapidly evolve your business logic to adapt to more and more models being deployed at the edge? Can you transform your current application into an agentic application, where the action becomes more relevant, where the action is based on a certain workflow. And that is an interesting angle to also explore. So, in conclusion, we've got, you know, proper planning, which needs ROI planning. It needs the type of hardware, the type of model, the type of benchmarking data at your disposal. Once all of that's done, it's the workloads themselves. What kind of use cases you already have deployed? Is it pure greenfield? Is it brownfield? Third, it's about scaling out of the lab into the operational sites as much as possible, orchestrating all of this through with as little overhead, with a lot of automation as possible. And finally, understanding the actual outcome. So, is it really helping you? Is it really reducing your costs? Is it really changing the way you're operating at the edge? With that, a quick overview of our platform. The Edge Intelligence Platform, where we are helping you create, secure, and operate edge AI at scale, is what we're after and what we'll talk about. We've recently launched this platform 2 weeks ago, and it is available to our customers. Most importantly, the three layers I'm showing you, the infrastructure layer, super important. That's where everything happens, all the magic in terms of managing the nodes, managing the infrastructure for applications. And then it's about the models themselves. How do we make sure the models are coming in, the right model, the right fit, and trained itself, fully curated or not? And finally, on top, the business logic with the agentic AI application. So just a quick preview of what that looks like. If you take hardware, in this case, we have partners like OnLogic and SimplyNUC, as well as Dell and Lenovo and Lanner and so on and so forth. We've got a lot of partners. As you bring that partner over and the hardware then connects back into this cloud securely, the idea is to deploy the Kubernetes infrastructure. Once that's done, then pick the right model. In this case, you can pick a Neutron model from the NVIDIA NGC catalog and package it with the right dependency, such as a VLLM, which is the inference engine itself. Once that's done, it gets deployed as well. And once the deployment's taken place, then you lastly tie it back into your agentic application. In this case, it could be a simple outcome-based logic that gets deployed to understand what sort of inference is happening and what alerts you want to set up. In some cases, it could be more complex. All of that gets tied to the right GPU, the right NPU, the right CPU, and off you go. So with that, I'll hand it over to Rob to do the product demo.
Thank you. All right, we've seen this in concept. Let's just dive right in. Thank you so much, Sachin, for making the demo so easy. There's so much I don't have to say that you've said in showing the value here. Okay, so we are logged into the ZEDEDA Edge Intelligence Platform. First thing I'm going to do is change organizations here. You get a really nice set boundary between environments commonly used for dev and staging and actual production. I'm going to switch over to our equivalent of production here. And we have a dashboard. It's clean, it's pretty, it's intuitive. It's all the things you would hope a dashboard is. We'll go through the full, well, pretty much everything here. But one other note on the interface. Right, this is a AI native. We have an AI assistant built in. This isn't like, one of those little chat bots like, hey, what do you need help with? This is MCP based. It has a ton of tools that are built into the system. You can administer your system from here. Right, so I can ask it, what models are available. Right, and so this has its tools. Obviously, it's MCP based. It'll go through and tell what models are in the model hub for this particular organization. And it's not just the querying, right? It's not just that you can get information about your system here. You can actually run your config from here, right? And as you would expect, there are guardrails, there are confirmations for any time you're going to change something. But I mean, this is as I'm sure we've all seen, this is kind of the wave of the future in interfaces in general. Okay, so we have this AI assistant. Let's actually dig into, this journey of getting, we've identified a use case. We know exactly what problem we're trying to solve. And, let's start at the beginning with, okay, let's find a model that can actually deal with this stuff. So we'll jump over to our sources here, right? This is where we're actually going to grab our models. And you can see here, we tie directly to pretty much everything, right? You can come in here, public or private, and give it your basic information here. Right, what do you want to call it? You can give it your secrets and so on. Right, hook this up to whatever you want, or just upload directly, of course. You can grab stuff out of your local file system. Once the source is in place, I mean, you can go in and actually look for, give me a vision model, right? And actually grab it directly from Hugging Face here. Right, we can just import this. And you can actually choose, I mean, really a cool thing, you can choose which of these you want to import, right? So, I mean, this one looks like this one is an NVIDIA, but if there are multiple formats available on Hugging Face, I mean, you can grab just the stuff that's relevant to your environment, which is kind of nice. It is important to grab the README, and we'll see why in just a moment. I mean, I probably didn't need to tell you that. You always want the README, but we'll see how that shows up in just a moment. All right, but you have the choice of what you want to bring down and what you don't want to bring down. Here. You can set some tags on it as you would expect, right? And you get your review. Here, we'll just import that guy. Once your models are in place, right? Either you've uploaded this directly or you've pulled it down from Hugging Face or NVIDIA or whatever else, shows up in your model hub. And this, let's do this one. So your model hub is your source for all the information about the model itself, right? I mean, here's the README. Shows up as the model card here. So this is directly from the model. We didn't put this stuff in. We can see specs, tags. We can see its metrics. We can see the versioning of it, right? The model lineage is really important at the edge, where you can see where you have potentially lots of different devices in similar but different environments where the models drift, right? So really, really important to have your version history here. So, let's say that, let's walk down this journey. We've identified a use case. The next step we're probably going to pick out 5 or 6 or 10 models and just kind of test the approach, right? See which one's going to fit best for our use case. And so as Sachin mentioned, benchmarking is a huge part of that, right? Hugging Face isn't going to go out and benchmark these models against your hardware. You're not going to see the performance on exactly what you have. ZEDEDA will show you that. Let's take a look. We can go to benchmarks, and actually here, let's create a benchmark for this model. I just add or here. So we can go through and this is the one we're benchmarking. Yes, okay. Sorry. Let's go back to benchmarks. We'll create a new benchmark for this model. Great, that sounds like a great name. We'll do this one. You can pick which versions of the model to benchmark, right? So if you've made a change to it, you can benchmark the old one versus the new. Let's just grab a couple here. Maybe that one. Right, so you can put as many models as you'd like here. And really a cool thing, if you're on the hardware evaluation side of the house, or if you just have disparate hardware, which the reality of running at the edge is you're going to see hardware diversity. You can run these against, let's run these against these 3. different types of hardware. And the way that you would actually get this hardware in is you would define these devices just for benchmarking purposes. We'll see that in a sec. Let's measure the inference speed. You can put some parameters around it. And these are fairly straightforward, right? You can set the load as you will. You can set the time as you will. Okay, we are benchmarking these models against these devices, and we'll hit it. And for this particular, this is a lab environment, so this one, we're not going to see it. Okay, so if we look at a benchmark here, let's grab one this one has a couple of different models in it. We can go into the benchmark results, and it's awesome, right? It's all of the stats that you need just as a first pass looking at how this model runs on this hardware, right? You can see temperature, you can see power usage, and of course you can see the all-important latency. If you want to see these as pretty charts and graphs, absolutely, right? You can see these over time. Right? Or you can just dig in and say, give me text results. Sort them as you will, right? The P95 is what's important to me. So I'm going to click on that and have it sort there. Right, so this is a full benchmark of this model running on your hardware exactly as it will be in the field, but really it's still just a first pass, right? So we've narrowed it down. We said, okay, this is a model that we like for our hardware, or maybe these are 2 or 3 models that we really like for our hardware that we think we want to run. Let's move them to the next phase. Let's make sure that they really do run the way that we want them to. And so what we would do, we would actually deploy that model with ZEDEDA's on-device agent, right? So when you go to deploy a model, and we'll deploy a model in a moment, when you go to deploy a model, by default, it wants to deploy the model alongside the on-device assistant, rather than your business logic application. And that's how it should be starting out, right? This actually lets you dig into the model itself. So this basically is an agent that we've built that ties an LLM of your choice to our application, which goes to the model itself, right? So we can, what endpoints are available on this model? We can go in, we can give it images to test inference against, right? This is basically an LLM assisted insight into the model. Makes it really, really easy to say, okay, this is the model that performs. We have it down to these 2 or 3 that perform well on our hardware. We're digging in further, and we find that this is the model that's really going to do exactly what we want to do. And so we have all that out of the way. That clears so many of these roadblocks that Sachin was showing you when traditionally trying to get AI out to the edge. Okay, so we've chosen our hardware, we've chosen our model, we've tested it out, we're ready to deploy it. Let's take a look at that. So let's jump back over to main interface and Zoom window, get out of the way. So we'll go back over to our models here. So we'll say I like this model. This is the one that I would like to run. I'm going to deploy it. Give it a name, and this name is probably already in use, so I'm going to add just a number there. The title, which is kind of a friendly name. Give it the description. So here, this is where, what I was telling you about earlier, where by default, when you go to deploy a model, it wants to run our eval agent. You can certainly run it alongside whatever you'd like. Now this is something that we've abstracted so far in on the AI side of the house, and it's gorgeous. You can deploy this to a single cluster. You can deploy this to 1,000 Kubernetes clusters at once. And in this case, it looks like the lab environment's not hooked up to the back end. When you go to deploy a model, right, it actually goes through this approval process. You'll see it pop up over here on deployments. And this is huge. This is a GitOps workflow that basically walks it through from when somebody goes to submit the deployment all the way up until it's deployed. Whoever submitted the deployment cannot approve it, cannot actually put it into place. It goes here and it's in review. So one of your MLOps admins is going to come in and actually look at this deployment and say, hey, is this something that is good? Is this something that we actually want? Is this something I want to come in and actually change this deployment? And yes, that's what architecture is it on, so on. Right, so you have total control here over deploying those models out. And it's really nice in that they're separated, right, completely from your business logic. The models have their own lineage, completely independent of the business logic side of the house. Okay, with that, it's great to, kind of do this traditional AI thing, which I can't believe I'm saying traditional AI, but the traditional AI thing of here's business logic, here's model. But to do this in the more modern way, to do this where you're actually making an impact, I mean, that's what an agent is for. That's what a full-fledged agentic solution is for. And so a full agentic solution is like that very early slide that Sachin showed you where you've got, I think you used NemoClaw. You've got the agent, you have all of the various containers that have the business logic, you have the inference engine, you have the models, everything kind of all bundled up into one package. That's an agentic solution. And it's deployed as a Helm chart. You can actually look here at the structure of the Helm chart. You can actually make changes as you go to deploy if you want one-offs. Right, you can actually get in here and edit it as you will. But this is how, this is where AI is going, right? This is where it becomes more autonomous and eventually, hopefully, nearly fully autonomous. This particular one I really like. This is one that we've done physical demos of, but this is essentially one where it's scanning PCB cards as they come through a factory. If it sees something it doesn't like with its vision model, it'll actually go through and talk to other components in the factory, right? If it says, hey, this something on this PCB is melted, it'll actually go back and talk to the PLC that's controlling the heat and bring down the heat. Really cool stuff. I mean, this is stuff that seems so futuristic, a year or two ago. Companies are doing this now. And ZEDEDA's found a way to make this really, really easy to do, as we've seen. With that, I've taken more than my allotted time. So let's jump right back into presentation here.
Thank you very much, Rob. That was a great demo and really interesting to see all the capabilities of ZEDEDA Edge Intelligence. We do have a few questions and we do have a little bit of time, so we'll go ahead and dive right into it. And I'll pass this on to both you, Rob, as well as you, Sachin. So the first one is that we already have a SCADA system running on older hardware. Do we have to rip that out to use ZEDEDA? So would one of you guys like to take that one?
Yeah, I'll take that one. So, I mean, we talked a little bit about it. The SCADA systems today out there, even though these are Windows applications, the common misconception here is that, you need to do a rip and replace. But here is where, we got to really figure out how do you future-proof this. So, with our Eve OS and the right hypervisor layer, we can bring on this application and then it becomes future-proofed. So the idea is to onboard these apps. They remain as is, they operate as they are over a virtualized hypervisor infrastructure, and then allow them to sort of continue to operate in the same way, get updated in the same way, but at the same time bring these containerized applications on the same physical hardware and do it that way. So now there is a transformation that needs to occur. Now, if your system, if your application is already running on an existing Linux system, then there's really then it's a simple transformation and migration. It's not a rip and replace. Yeah, back to you, Al.
Looks like you're muted, huh?
Yep. Yeah, so it sounds like so you can basically use your existing uh, SCADA systems alongside the new AI capabilities. We also got another one, which is this. What are the top three challenges that Zededa is focusing on, and where do you think Edge AI as a technology is going next? Would one of you guys like to take that one?
Oh,
Yeah.
Sergeant, that's all
So
you.
yeah. So the top three challenges as Zeta is focused on is, so first and foremost, we want to make sure that we can onboard uh, and make this journey as smooth as possible for our customers. So that means that the customer experience has to be taken into account for not only deploying nodes at the edge or Kubernetes at the edge, but also in the same format, deploying models at the edge and then deploying these agentic apps. So that's the first and foremost challenge that we need to address. How do we continue sort of evolving the platform so that it's an easy experience for our customers? The second challenge is going to be around ensuring that we can manage the diversity of the hardware. So we are working with our partners. I mentioned a few of these, and the idea is to actually now do both sides. So one is work with the ODM partners, bring the full system like an on-logic hardware that already has a baked-in CPU or GPU, but also work with the chip partners. So work with NVIDIA to actually understand as they evolve their edge inferencing capabilities. So NVIDIA started with, say, Trident inference engine for the Jetson hardware, and now they moved to Dynamo. And then they recently launched Edge SDK LLM for the Gen AI part of it. Then there's a VLLM inference engine also, which is sort of more open. Now bringing all these different ecosystems directly on the chip, making sure it works out of the box, working closely and bridging that gap from a chip point of view to then the system point of view, from the hardware point of view, and then all of that, packaging it up and then making it easy for our customers to consume. That's sort of the second biggest challenge for us. And obviously the third is looking a bit ahead and thinking about the future and where this is heading and enabling that, just before our customers actually start asking for it. So.
That's great. Thank you very much, Sachin. We got another one, which is what is the difference between edge inference and what you're calling agentic edge AI?
Yeah, that's a good question. I mean, I think there's a lot of confusion in the market around edge AI, agentic AI, agents. Different words get thrown around. The way we are defining this is that number one, the inference, the model itself is producing an output, which is basically the inference action, and that inference output really is, some sort of a detection of an object. It's a classification of a certain type of object. It is a flag that gets, turned on based on an anomaly that you're trained for. So these are outputs. Then once these outputs are generated, then these sort of have to be then sent to something else. In this case, an agentic edge AI app that then comes and closes the gap in terms of what to do with these outputs. So it's not just detecting that's part of the problem, but then how do you act on it? So acting on it means either slowing the production line down, maybe rerouting sort of an inspection that needs to happen as part of a workflow, adjusting a control parameter in real time as needed. Like one of the examples was the well site, right? Turning off the walls, turning on the walls, as much as possible to manage the yield. So these actions are what are embedded into the agentic apps. And we are calling these as agentic apps. They're also, sort of used as agents that are running in a certain autonomous fashion. And we talked about autonomous and autonomy as well. Autonomy is how much autonomy you give, how much freedom you give your application or your agent or your agentic app the ability to make a decision on and to act on certain input from this inference output. So the level of autonomy changes over time, and we are closely monitoring this with our customers, how comfortable they are with keeping the human in the loop versus keeping the human out of the loop for certain decisions.
Gotcha. Thanks. So it sounds like inference is detection and agents are about action. I guess to the
Yeah,
simple way I like to break it down. Another question we got is right now you are focusing a lot on industrial IoT and computer vision in defense, et cetera, segments. Where do you see Edge AI going for residential markets like sensors for swimming pools, home appliances, residential robotics, and so forth? Not really our main area of focus, but maybe we could just go ahead and address it for
yeah,
the
absolutely.
attendees.
I mean, look, the market is, the business far edge, what we call the remote edge for energy sector, for automotive sector, for you know um, the solar or the defense or healthcare, right? There's a lot of different use cases. Similarly, in the residential segment, AI is playing a significant role, right? So, uh, bringing the ability to deploy agents like OpenClaw into your home and giving them a little bit of, autonomy to manage your appliances, to manage your energy within the home, to manage the power, where what turn off, what to keep on, maybe to even turn off the Wi-Fi, turn on the Wi-Fi, parental control. All of these are going to evolve. So it's a matter of time in terms of what happens. However, you do need all the sensors in the home. You need all the sensors to feed all this information back. So there's still that ability to first put all the hardware in place, these little sensors, and then be able to run AI to make this level of automation happen.
That's great. And we've got time for one more. So, what happens if you have to update models across hundreds of of edge devices? Do you have to SSH into each one?
Yeah, so uh, so they when you're managing hundreds of these models across thousands of edge nodes, right? I mean, this combination is significant, right? It's a one to N or N to M relationship here. The approach that works is really looking at it from different angles. First and foremost, do you have the right automation in place? So we built the platform, which basically builds this lifecycle into the picture. So first, we will version the model, so you know which version is being deployed on which hardware. Second, we'll benchmark these models to give you the performance and update, let you know that, certain things do not really fit on certain hardware. So don't even try deploying it. Like deployment will fail. And then, when we sort of go into this mode of deploying, we also added some form of governance. So the idea is that someone has to approve which model gets deployed where. And that oversight is super important when it comes to the IT and the OT split, because the OT team is really what's on the ground. And they know, even though the IT team might be wanting to deploy a certain vision model at the edge, the OT team knows they need to wait for a week, a day, or 2 days before they approve that. So that governance is super important. And then finally, obviously, observability and rollback. So these all capabilities are built into the platform, and that's how you don't have to log in into all of these devices and manage all these models all at once.
Great stuff. Thank you very much, Sachin and Rob. We are at time. We're at the top of the hour. So I just want to thank all of you for attending today's webinar. I do encourage all of you to check out ZEDEDA.ai to learn more about how you can bring AI to your edge operations. And with that, I'd also like to encourage all of you to contact us at ZEDEDA.ai. And you can also email us, info@zededa.com. So with that, thank you very much for attending. Again, we will make the replay available on our website. So please go ahead, take a listen to it, share the replay with all of your colleagues, and I hope all of you have a great rest of your day. Thank you very much.